time to factor out, but don't freak out. All right? So, factoring out, what does that mean? Well, first you have to understand what a factor is. So, to get an idea of what a factor is, let's just write down a number. Let's write down the number 8. All right, so what are all the factors of 8? That is, what are all the things that we multiply together to get 8? Make a little tree. What times what equals 8? 1, 8. 1 times 8 equals 8. 2 times 4 equals 8. Is there any more? 3 times anything? No. 4, well, yeah, 4 times 2. So 1, 8, 2, and 4 are our factors. Things that multiply together. So multiplication is huge here. That's what we need to make sure we understand. Multiplication tables are really going to come in handy. So factors are the things that we're going to be multiplying. So when we're talking about pulling a factor out, pulling something we multiply out. You say out of what? Well, let's say we have something like, I don't know, 2x plus 6. You've seen this before. Notice there is no equal sign, so we're not solving anything here, because we can't, there's no equal sign. All right? So we're just going to change the form of this. We're going to change what this looks like, but we're not going to change the value. And I'm going to factor out, we're going to undo a multiplication. All right? And so there's a couple different ways to do this. If you're used to factor boxes, you can have this box here and put everything inside the box. This is just a 1 by 2 box. And then figure out what goes on the side and bottom. All right? So you could have like something that's got to go here and here and here. So 2 times x is 2x. 2 times what is 6? 3. And then from here, the last step would be to write it like this. This, I have factored out a 2, a factor of 2. And I can check my work. What happens if I distribute this? This is my answer, but if I were to check 2 times x, and then 2 times 3. So 2 times x would be 2x. 2 times 3 would be 6. So I know this is the same. All right? You're used to doing this. Now we're undoing that. Okay? You don't have to do a box every time. If you like the box, use the box. If you like to think outside of the box, you're more than welcome. All right, so it gets a little bit more difficult. So let's say we've got 3x plus 12. So I'll skip the box. I got to look at this part, and I got to look at this part, and I got to say, all right, what are the common factors here? It doesn't have any x's in this one, so it's not going to be an x, but it will have a number. So the biggest factor that I can pull out is really what I want to do. Because I could pull out a factor of 1, right? But that doesn't really help me. I just pulled out a 1. That's really pretty useless, because then it doesn't do anything for me. So I want to pull out not only any factor, but the biggest factor possible. So I'm going to pull out 3. And that's going to be 3 times x is 3x. 3 times something equals 12. 4. So this is factored form, where we have factored out a 3 of this. Really useful, because when I can do this, and I can look at things in different forms, I can simplify things easier, and that comes into play later. All right? But now, what happens if I've got more something that's more complicated? Like, what if that was a 3x squared plus 12x? Well, now I've got well, I'm going to put this in the box just so you can see, but I've got a 3x squared here, 12x here. I can pull out a 3, and I can put an x here, but x times 3 is not 3x squared, so I need another x. If I put x squared here, this box works, but then I would need a 12x here. Not a 12x, a 4x, I'm sorry. 4x. And I've got something down here, like this. These two things still have something in common. They still have a common factor of x. So what I really want to do is pull out a 3x, multiply times x, and 4. So when I'm all said and done, I've pulled out a 3x. And notice that when I'm finished, what's in parentheses here has nothing in common. So the x and the 4, there's no common factors with them anymore, except for 1. So 3x times x is 3x squared, 3x times 4 is 12x, and I'm good. And this is my answer. I have factored out a 3x. And I can continue with that process. I can go back and I can say, okay, what if I've got 4x to the 4th power plus 12x to the 3rd power? Then I can pull out, okay, well let's look at the numbers first. I know I can pull out a 4. What else can I pull out of here? Well, I can pull out an x, but x to the 4th, that's x times x times x times x. This is x to the 3rd, that's x times x times x. So the most amount of x's I can pull out is 3 of them, because I can't pull 4 from here. So this is x to the 4th. Oh, I'm sorry. Making all kinds of mistakes. 4x cubed times what is going to give me 4x to the 4th? X plus 3. And you can check your work and say 4x cubed times x, that's going to give you 4x to the 4th. 4x cubed times 3, that's going to give you 12x to the 3rd. So if you've got exponents to bigger powers than 2, you're going to have to go back and watch the other video on how to simplify exponents, which is more complicated. That's how you do that part. It'll all come into play when you do things with adding and subtracting fractions with x's as well, because you'll have to change the form of it. I'll go into that eventually, and that's it.